This is the Tower of Hanoi. It's a kids game that you might already be familiar with. The goal of the game is to move the rings from the leftmost tower to the rightmost tower. The only catch is you cannot take a smaller ring and then stack a bigger ring on top of it. So this would not be allowed. Now, even though this is a kids game, it can be quite interesting and it's going to help us understand the power of recursion. By the end of this video, I want to write a computer program that can solve the Tower of Hanoi. But before we write a computer program, let's try to understand how to solve it manually. Instead of worrying about a Tower of Hanoi that has 7 rings, let's worry about a Tower of Hanoi that only has 1 ring. In this case, it's pretty obvious what we have to do. We take the ring from the leftmost tower and move it to the rightmost tower. Now what if we had 2 rings? Well, if we had 2 rings, it's still pretty obvious. We take this small ring, put it on the middle tower, take the big ring, put it on the rightmost tower, and then take the small ring from the middle tower and put it on the rightmost tower. Now what if we had 3 rings? Let's see, how do you think we can solve it then? The basic idea is we have to take these 2 rings, somehow move them to the middle, take the 3rd ring, move it to the right, and take these 2 rings and move it to the right. We know how to move 2 rings of a Tower of Hanoi, right? We did that in the case when the Tower of Hanoi had 2 rings. Now, if we had 4 rings, then again, what we want to do is the same thing. We want to take these first 3 rings, somehow move them to the middle tower, take the 4th ring, move it to the right tower, and take these 3 rings and move them to the right tower. Let's create a function that can move n rings from one tower to another, and this function is going to take in these inputs. It's going to take in the number of rings, the from tower, the to tower, and the intermediate tower. Let's implement the base case, which is if n is equal to 1. In this case, we have to move the topmost ring from the from tower to the to tower. In any other case, what we want to do is we want to move all the rings that are on top of the biggest ring to the intermediate tower, move the ring from the from tower to the to tower, and then move the ring from the intermediate tower to the to tower. So let's do that. First, we want to move n minus 1 rings from the from tower to the intermediate tower, and the intermediate tower in this case would be the to tower. And then we want to move the topmost ring of the from tower to the to tower, and then after that we want to move all n minus rings from the intermediate tower to the to tower, and in this case the intermediate tower is the from tower. So the intermediate tower is just the tower that's not being used. It needs to be passed in so that the output is correct. So let me show you how this works. Let's say we pass in ns2, the from tower as tower 1, the to tower is tower 2, and the intermediate tower is tower 3. Then it's going to tell us all the steps we need to move all the rings from the from tower, which is tower 1, to the to tower, which is tower 2. And we can actually verify that this works with our actual Tower of Hanoi. Let's get more adventurous and see whether this works when there are 4 rings. And to make the steps more clear, I'm going to call the from tower the left tower, the to tower the right tower, and the intermediate tower the middle tower. And just like that, I have all the steps I need to move 4 rings from the leftmost tower to the rightmost tower.